Hello everyone. In this chapter 4, we'll talk about product and service design and various aspects associated with this. So let's start with the next slide, which lists basically product or service design activities. Now, these 7 activities are like generic in nature. It can vary slightly from a type of business to another type of business. So one of the key activities is to translate customer wants and needs into product or service requirements. Now, this is done using a very commonly used tool for doing this is QFD. So we'll talk about QFD in more details later in this chapter. Refining existing products and services. So this is another activity every company goes through. If you take example of automobile companies like Ford, they come out with new model year vehicles every year. So if you go to their showroom today, you will see that they have 2012 model year vehicles. So if you compare 2012 versus 2011 model year vehicles, there will be slight improvements, which they do based on customer complaints or warranty claims or customer feedback. So or it could be like some changes in technology. So from time to time, such improvements are done. So that's what is like refining existing products and services. Develop new products and services. So this could be totally new product. Like when Apple came out with iPad, so this kind of a tablet did not exist in past. So they created a totally new market. Formulate quality goals. So while designing is important to remember and formulate what quality goals will be. Like if somebody is designing an engine, so they should know that, for example, what should be its life? Are they targeting, say, 10 years of life or 12 years, 15 years, 20 years, 30 years? So what will be the life? If somebody is measuring it in terms of how many miles a vehicle will be driven with that engine, so whether it will be 100,000 miles or 150,000 miles, 200,000 miles. So those kind of quality goals are formulated. Formulate cost targets. So obviously, while designing new products and services, cost is very important because we do not have unlimited supply of money for doing or working on any new project with respect to design. So everything has a budget, and within the budget, things work out. So formulating cost targets is very important. Construct and test prototype. This is another activity. So before somebody can release an order for mass manufacturing, all kinds of testing is needed. So for that, people develop prototypes and see how it looks, how it works, and all kinds of testing will be done on that. Only when from all angles everything is okay, then only it is released for final production. And then all such activities which go on, they are documented. So, and also not only that, for the products and services, what will be the specifications, like dimensions, their tolerances. So everything is documented because these things go to so many different people, not within the company, but outside the company. So various suppliers will be involved, various like where a company does subcontracting or outsourcing. So because these people are located all around the world, so they have to be communicated properly, and documented specification basically helps in that. What are the reasons for product or service design? So as you see, there could be so many reasons behind that. The reasons could be economic. It could be that the demand is low. So if somebody designs a product or service for which demand is low, so a company has to respond to that. So they have to make modification, they have to change few things here and there. So that will call for, again, doing product or service design. It could also be high number of claims. So if the product is sold with warranty and it is found that it is having a lot of problems in the field and customers are complaining. So obviously some modification will be needed. It could also be due to social and demographic factors. So things change, like people talk about baby boomers. So that population, as they age, they will have a need for specific products and services. So those things will have to be developed, keeping in mind those kind of demographics. Another reason is political, or it could be some lawsuit, or it could be some other legal issue. So that also leads to changes. If you look at different countries, they have different types of laws. So what may work in the US may not work in, say, Iraq or maybe Afghanistan. So some modification or design changes are required to take care of that. It also could be because of the competition. So for example, when iPad 1 came, it did not have camera, but as soon as their competitors started bringing products with cameras, so in iPad 2, Apple included a camera. So such changes are basically as a result of competition. It could also be due to cost or availability. So if something is very expensive, or maybe some raw material is not available readily, so obviously the design has to be changed so that they can do it at a lower cost and some other material. It could also be because of technological advances which are happening. Now, what are the objectives of product and service design? The main focus is always customer satisfaction. So because customers are going to pay for these products and services, so they have to be satisfied. So there is no two way about that. Understand what the customer wants. So that's very important. So other focuses could be function of product or service. So what function that product or service can provide. It could be cost related or profit related. So it could be like a company wants to make changes to the design so that it can be manufactured probably at a lower cost and thereby increase the profit for the company. So that could be another objective or focus. Quality is always very important. It could be appearance, ease of production or assembly, ease of maintenance or service. So all these things could be the objectives for making design changes. Designing for operations. So as the name suggests, while designing, operation activities are taken into account. So what are the capabilities of the organization in designing goods and services? So if somebody in the design department comes out with a very interesting product, very innovative product, but if it is going to be difficult to manufacture it, if it is not possible to manufacture with the current resources, so obviously there will be a lot of problems down the road. So designing for operation means at the time of designing, all such factors are taken into account. If it is not, which happens actually many times, that causes low productivity. So a designer may say that this product should have such and such specification, whereas in the production they struggle to produce with those specifications because they are very strict, very restrictive. So obviously the things will slow down and the productivity will go down. It will also affect quality, and obviously if productivity suffers, quality suffers, cost will go up. FDA stands for Food and Drug Administration. So they have their requirements. Then OSHA stands for Occupational Safety and Health Administration, and IRS. So all these legal bodies actually they have their very strict requirements which companies, if they want to bring out products and services in that area, so they have to take into account the guidelines provided by such kind of agencies like Food and Drug Administration. So they are like watchdogs. So they continue to monitor products and services for the company and see that they are compliant with their requirements. Product liability. So a manufacturer is liable for any injuries or damages caused by a faulty product. So for example, if an automobile company has sold a vehicle, when the customer is using that vehicle and there is a brake failure because of manufacturer fault and the driver gets injured because of that, so obviously such things should not happen very often. You may have heard of NHTSA. So they continue to monitor such things, and if the complaints start to spike, which can cause harm to the driver, then they go after these big automotive companies, and sometimes it ends up into quickly recalling those vehicles for important repair, which corrects the problem. There is uniform commercial code. So products carry implication of merchandisability and fitness for use. So when a product is sold to the customer, it should be fit to use. So manufacturer should not be selling something which is not fit for use. Fit for use in the sense of intended purpose. So that is governed by uniform commercial code. And then there are ethical issues like releasing products with defects. So that will obviously create a problem for a company which is doing such thing. And then environmental. So environmental protection agency, EPA, monitors if any such guidelines or rules are broken. For example, for automobile companies, there is a specification for the emissions, how much emissions can be tolerated. So those are developed by EPA. Designers adhere to guidelines. So while designing these innovative products and services, they have to adhere to some specific guidelines. It could be related not only to the outside agencies or government agencies, but also internal. So product designs that are consistent with the goals of the company. Give customers the value they expect. So all these are like key principles they have to follow. Make health and safety a primary concern. So this is not only true for the customer, but also when the design goes out to, say, manufacturing for production. So those people should be able to make such a product in a safe and healthy environment. Consider potential harm to the environment. So all such things. For example, the last one, different countries may have different regulations. So the amount of emission which may be allowed, let's say, in a developing country may be different from the amount of emission which may be allowed in a developed country. So such things also vary. And when any company is competing globally, so obviously they have to take into account all such issues. Now, another issue they have to take into account relates to life cycle. So for any product or service, sometimes they have what is called as a life cycle. So there is an introductory phase when that product or service is introduced to the market. So in this phase, there could be a situation where the product could have some bugs because it may not be 100% perfect in the sense that it has not been tested in the field. So because it is introductory phase, the demand you can see on the y-axis is initially very low because people may not be aware of the utility or what benefit that new product or service is going to give them. So that's the introductory phase. And then when they start getting feedback from the customers and things like that, then they correct those problems, and customers also, by the time they come to know more and more about the product, and it enters what is known as a growth phase. So you can see the demand increases very quickly. And then that product may reach a maturity stage, because that will be a sort of saturation. So the demand increase is not very high. It is very, very minimal. You can take example of a research in motion company, which is based in Canada, and their product, the popular product is BlackBerry smartphones. So initially, when they introduced it, obviously demand was very low, and slowly it started picking up, and they also started making improvement, and then it reached a maturity stage. And at this stage also there could be so many competitors in the field, and their market or the demand for their product may start going down. So at the decline stage, a company has to make a conscious decision whether they should make a drastic change in design so that they can make their product more attractive to the customer, or should they discontinue the product so that they don't need that extra capacity, so they can reduce cost. So in the decline phase, basically they need to take a very specific step, either discontinue it or maybe make a drastic change so that people get attracted. Now, not every product might follow all these phases, all these life cycle phases. So if you take example of, let's say, pencil, so a wooden pencil, so this has been used for a long time and continue to be useful still. So there is no such phase like introduction, growth, maturity, decline. This is an almost flat line. Similarly for maybe glass. So things which are used or people find useful in every situation. Now, another important issue at the time of design is standardization. So standardization, as the name suggests, is the extent to which there is an absence of variety in a product, service, or process. If there is a part, for example, that can be used, let's again take example of automobile company. So if there is a part which can be used in every vehicle line for this automobile company, whether it is a car or a truck, or like within car also different types of cars, different brands. So if a part can be used across the board, so obviously that will have a lot of advantages. Fewer parts will need to be designed because they are being standardized. There will be reduced training costs and time, because once you are dealing with less and less number of parts, so training costs will be low. Easier purchasing, handling, and inspection. Orders fillable from inventory. Long production runs and automation. So because you can produce them in bigger number, because they can be used in different vehicle lines, so obviously that will be advantageous. But it will have disadvantages also, that it will be difficult to modify design after freezing it. For example, if there is a part which can be used by Ford in, say, Ford Focus and F-150. Now, if some changes are made with respect to Ford Focus, which requires some change in that particular part, then obviously it will affect all other lines, whether it is 150 or any other vehicle line they have. So it will be very, very difficult to modify the design in that sense, because now it is being used in so many different vehicle lines. So design changes are not going to be easy. Even if it is very important, it is going to become a bit difficult. High resistance to improvements. So obviously people get familiar with it, comfortable with it, so there will be high resistance to even improvements. Decreased variety results in less consumer appeal. So That is another disadvantage. Now coming to the next slide, which is another issue called mass customization. So mass customization is a strategy of producing standardized goods or services, but incorporating some degree of customization. One method they use is called delayed differentiation. So producing but not quite completing a product or service until customer preferences or specifications are known. So one good example of this is in men's clothing. Like if somebody wants to buy a suit and the legs of those pants are not like ready. So depending on the size of the person or the length, they can, once they get the exact measurement, they can complete the remaining part. Another method is for mass customization is modular design, which is a form of standardization in which component parts are subdivided into modules that are easily replaced or interchanged. It's like in a car you have engine. So engine is you may say is one module, and then the transmission could be another module. So if something major happens to the engine or transmission, so the whole thing can be taken out and replaced by a new engine or transmission. So it allows easier diagnosis and remedy of failures. So problems can be corrected more easily, especially if it is a severe problem. So easier repair and replacement, simplification of manufacturing and assembly. Now the next slide, the issue related to design of products and services is reliability. So this is the ability of a product, part or system to perform its intended function under prescribed set of conditions. Generally, this prescribed set of condition is normal conditions. Reliability and quality, in a way they are related. You may say reliability is quality over time. So if a quality is maintained over a period of time, that's called reliability. For products and services, obviously, reliability is considered very important. If it is not reliable, then a product is said to fail. So situations in which a product, part or system does not perform as intended, so then it is called a failure. So prescribed set of conditions or normal operating conditions, they are the set of conditions under which an item's reliability is specified. So the reliability will be applicable only when the product or service is operated under those specified conditions. For example, a computer, you would assume that a computer should be used under normal conditions, means that around room temperature and things like that. So obviously if you put that into water, it may not work. That's not normal operating condition. So improving reliability is like one of the continuous activities a designer has to work on. They always look to improve reliability. So it involves a component design, because ultimately the entire product is made up of many components. So production assembly techniques are used. They use testing. After designing, it has to be tested. Sometimes some products come with redundancy or backup. Like they may have two of them. So even if one fails, the other one keeps on working. So in some aircrafts, you have like two engines. If one engine fails, the other one works. So that is redundancy or backup. Just like in human body, you have two kidneys. So even if one kidney is not working, still the basic functions can be done. Preventive maintenance procedures also help to improve reliability. This is like if you compare this with breakdown maintenance. So preventive maintenance is always considered superior to breakdown maintenance. So if I have a car, if I take it for repairs only when it fails, that's not a good strategy. But if I do some preventive activities like oil change, regular oil change and things like that, so that will increase reliability. User education also is important because sometimes uh, a product could be misused, so users should be educated in its proper use. And then system design is another important thing for reliability. Another issue is what has become very, very important nowadays is called robust design. And robust design was popularized by a Japanese engineer, Dr. Taguchi. So Dr. Taguchi actually has been considered as the modern quality guru. And he has written a lot of books, provided so many innovative methods for robust design. When PCs were new, like late 80s or early 90s, so that time it was a requirement that they should be operated in an AC room, air conditioned room. So obviously we can say that that time they were not robust, but nowadays they are robust enough. In fact, Lenovo's new laptop has been designed in such a way that even if you spill a coffee over it, they have made passages through which that liquid can ultimately go out of laptop without harming anything. So it will still function even if by mistake it is misused. So that's an example of robust design. So even if the conditions are not conducive for the product, still if it can operate efficiently, it is called robust. So Taguchi's robust design approach has been popularized by so many different companies like Ford and General Electric and so on. So what it says is design a robust product. So insensitive to environmental factors either in manufacturing or in use. So what Taguchi says is that it is very difficult, in fact impossible to control the environment of the world. So we cannot control like humidity of the world or temperature and things like that. It's very difficult to control that. In fact, impossible to do that globally. Because we cannot do that, why not make our product in such a way that even if there are variabilities in those conditions like humidity, temperature, and all those things, still if our product can perform consistently, so that will be called robust design. So the purpose or the aim at the design stage, obviously this cannot be achieved at manufacturing stage. It has to be implemented at design stage itself. So the central feature is parameter design. So how to do that? He has given a lot of methods within parameter design where the variables or the design variables are optimized such that the product can become insensitive to outer conditions. So in this, it determines factors that are controllable and those not controllable. So we make a list of those factors which can be controlled and then make a list of those factors which cannot be controlled. And then their optimal levels related to major product advances. And then those which can be controlled, we choose their levels wisely so that it can make it robust. Degree of newness. So if you look at just a modification, then newness of the organization is low because it is a slight modification, some small tweaking of the design. And customers may not also notice it. It may be a small modification. If it is expansion, still it could be low for both company and customer. Clone, for a company, it could be very high, like if there is a successful product out there, not by this company, for the company, obviously, when they decide to make this new product, it will be high. But customers have already seen it. Like when iPad came into the market, And when Motorola came out with Zoom, so obviously for Motorola it was something new, but for the customers they have already seen that kind of product. So it was not very new from customers' perspective. And then the last one is totally new design. So it could be something which is totally new for the company as well as customers. And this is not very often. This is not something which is done very often. So nowadays, because of globalization, the product design efforts, obviously, everything happens. It's not that a single person sits and designs a new product and service. There's always a team. But because of globalization, now we have to deal with what is called as virtual teams. A team may consist of people who are located at different parts of the globe. So there could be, maybe if we again talk about automotive companies, so a design team can consist of designers maybe sitting in Detroit, sitting in maybe China, maybe India, Japan. So what happens is, one disadvantage that causes is, if you talk about face-to-face meetings. So face-to-face meetings are not possible because it is going to be very, very expensive for all the people to meet at one point. But nowadays, because of advances in technology, people use methods where they can talk to each other very quickly. They can share information on their computer, share the design information. So all such things can be done almost in a real time. So uses combined effort of a team of designers working in different countries. So provides advantages such as engaging the best human resource around the world. If you talk about like software, when Microsoft develops say Windows 8, obviously that is not entirely done in US. They have team of engineers sitting in US, China, India, and all these people collaborate with each other to come out with the product. And sometimes to speed up, when the US designers are working in the daytime here, it's night in say India. So they get rest, and same project can be taken up by when it's night in US. So in daytime it can be taken up by wherever US engineers left. So Indian engineers can start working from there. So that is another advantage. Because of that, it is possible to operate on a 24-hour basis. So the work never stops, it keeps on going. Global customer needs assessment. So that will be possible because of the nature of this arrangement. Global design can increase marketability because different people are involved, so marketing also will be easier. In this slide, 9 different phases are listed for product development process. So these are like general phases. So any product development, it always starts with idea generation. So from idea generation to finally follow up evaluation when the product is already in the field. So all these different activities go on, like feasibility analysis, product specifications, process specification, prototype development, design review, market test, product introduction, and so on. We will look at some of these individually. Now, if you look at idea generation, there are like different sources from where ideas for new product or service can be generated. It could be based on supply chains. Nowadays, supply chains are global. So a company is connected with so many different companies throughout the world, and it gives them a lot of ideas, new ideas, how others are working on a specific area and how they can include those best practices to improve their own design. It could be competitor based. Like a company sees that their competitors are doing something in a very good way. So they can incorporate those best-in-class actions into their products. One example is reverse engineering, which was done by Ford. when they designed Taurus, which became very, very successful in 90s. And Ford was having tough time before that, but the success of Taurus made them very profitable. So in that project, basically they looked at various best-in-class activities or design activities which other competitors were doing, and they incorporated all of them into one product. So that's called reverse engineering. So you start with like what is already available and what is the best, and using that you create a design. And the ideas are also generated using research. So there are three different types of research, like basic research, applied, and development. Now, in basic research, immediate goal, you may say, is not commercialization of the idea. So it is generally taking research forward. But in applied research, the aim or the objective is also to commercialize it. So the ultimate aim is to profit from that research idea. And development is basically taking those ideas and then try to put them into action. Designing for manufacturing. So when people are working on design activities, it is sometimes very easy to just focus on their work and try to come out with the best possible design. And many times that creates problems down the line, especially in manufacturing. So because of that, people came out with this concept of designing for manufacturing. So the idea is that while designing itself, you look at the manufacturing capabilities and resources, and then make those designs so that they will be more easily produced. The designer's consideration of organization's manufacturing capabilities when designing a product. So when it is overlooked, a lot of problems occur. This has been seen actually in many suppliers of automotive companies earlier, where the design was sent from the automotive company to the supplier, and the supplier had all the difficulty in the world to make those products with those specifications, because if they did that, they had a lot of trouble during assembly. They were not able to assemble those parts if they manufactured as per the design. That happened when design for manufacturing was overlooked. So the more general term, design for operations, encompasses services as well. So this is also applicable. So there's a term called concurrent engineering, is bringing together of engineering, design, and manufacturing personnel early in the design phase. So at the design stage itself, the team should include manufacturing people also. When it is done, it is called concurrent engineering. And in fact, that small step can be very, very beneficial for the company. Designers also nowadays use CAD a lot, computer-aided design, which helps them to increase productivity, and also they can create database for manufacturing, and they can use such information in future when they are trying to redesign or even coming out with totally new design. Component commonality. Multiple products or product families that have a high degree of similarity can share components. So we talked about briefly earlier about this. So automakers use internal parts like engines. So one engine can go to more than one vehicle line. Same thing for transmission. So, and water pumps and so on. So the benefits are reduced training for assembling and installation, and reduced repair time and cost, because the same or common component is being used. So that is always useful. Now, initially I mentioned to translate customer wants and needs into technical specifications, we use QFD. So this QFD is quality function deployment. So this is a tool to capture voice of the customer. So as it says here, an approach that integrates voice of customer into product and service development process. So let's look at one example. So one example of using QFD, it's called house of quality. So the outcome of doing quality function deployment, all the information gathered is organized into what is called as house of quality. So you can see there are customer requirements in the left room. So in this house, there are so many different rooms. On the left room, you have customer requirements. So customer requirements are basically those needs and wants which customer have. What design requirements will be needed so that those customer requirements can be fulfilled. So using those two, a relationship matrix is created. So by relating customer requirements to design requirements, relationship matrix is created. And then on the right side, you also bring into picture the competitor. So people take competitor's product and rate them on a scale of sometimes 1 to 5 on different parameters. And now with respect to the design requirement, they have the specification and target values. Now within design requirements, there could be some correlation. So that is the roof of the house of quality. So if you look at example given on the next page, this is about door of a car. So the customer requirements, if you see on the left room in the house, customer says, now sometimes customers may say very vague things, but then that has to be translated into technical requirements. So they may say it should be easy to close, and that is most important, 7 points out of 10. Stays open on a hill, easy to open, doesn't leak in rain, no road noise. So somebody is driving the vehicle, it should not make a lot of noise. So all such things are captured by engineering characteristic, like what should be the door seal resistance, what should be the energy needed to close the door, and so on. And then out of these various variables, there could be some variables they are correlated to each other. So that's represented on the top. So if there is strong positive correlations, we use this symbol. If it is positive, just a circle, negative cross, and strong negative star. And then you have the competitive evaluation on the right side. So two competitors, A and B, along with X, which is this company. And then you have the technical specifications on the bottom. So much of actually useful and critical information is captured or summarized in the form of this house of quality. So QFD plays a very important role. Obviously, the people who will be using this will be from marketing, operations, you have the designers, and maybe manufacturing people. Kano model, which is very, very popular, especially for the designers when they are designing new products and services. So as the name suggests, it was developed by a Japanese professor, Professor Kano. On the x-axis, you have extent of customer wants in the product. And y-axis, you have customer satisfaction. So those three lines, they indicate the relation. So if you look at the first one here, every product or service has must-have characteristics. So that's the bare minimum. Everybody expects that. That has to be there. So if it is not there, the customer satisfaction will suffer. But if it is there, you can see it is not going to increase the customer satisfaction drastically. Like for example, if you go to a restaurant and order a coffee, so you expect the basic requirement that the cup in which coffee is served is clean. If it is clean, that is a must-have characteristic. It has to be clean. because if it is not clean, then it will decrease the customer satisfaction. But if it is clean, it's not that it is going to be very exciting. It's not that you'll jump out of your chair that the cup is very clean. So that's not going to happen. So even if these characteristics are present, they have to be there. If they are present, they are not going to drastically increase the customer satisfaction. But there could be characteristics which are expected. So you can see the line is straight, means as more and more of that is there, the more and more customer satisfaction will be there. For example, if you are looking for a car which is fuel efficient, so more and more fuel efficient it is, higher and higher will be customer satisfaction. So that will be linearly related to this variable. Now there could be some characteristics which are excitement characteristics. So you don't expect them, but when you see or experience them, you get excited and very happy. So that means the more and more you see those things, higher is the customer satisfaction. That's why that line goes up drastically. For example, if you take an example from the past, maybe 10 years back, a cell phone was, the basic purpose was to talk, so that you can talk anywhere you go. Now suddenly a manufacturer came out with a cell phone which has a camera. So that was an excitement factor or characteristic. So problem with excitement characteristic is that after some time, those characteristics become must-have characteristic. Initially, it may excite you, but when it becomes a common feature, you see every phone has a camera, then it is a must-have. If it is not there, then you feel unhappy. But if it is there, who cares? So this is something which is this Kano model, which is used by, I think, every design engineer, and obviously marketing, operations, everybody is involved while determining and classifying those characteristics into these three characteristics. So as we have learned in the previous chapter, service is something that is done to or for a customer. So in manufacturing, the time gap between a product creation and its delivery is sometimes very large. So a product may be created, and by the time a customer gets it, it could be sometimes more than a year. So, but in services, the time gap is almost absent. Sometimes as the service is being created or being delivered, so there is no gap. So that creates a lot of problems. Service is something that is done to or for a customer. Service delivery system, the facilities, the processes, and the skill of that person. And sometimes we have like product bundles, which includes both products and services. So it could be true for a cell phone also. So you have goods there as well as services. Service package, the physical resources needed, the goods that are purchased or consumed by the customer, and there could be some explicit services and implicit services within a service package. For example, if you go for filing your tax and say you go to H&R Block to prepare your taxes, so certain things are explicit. So what is expected in terms of service, that will be very, very explicit. But there could be things like courtesy, friendliness, and how they talk to you. So those things are implicit. It will not be written somewhere that they will provide these kind of services. So there are different phases in a service design. So it starts with conceptualization. So somebody thinks about that this is something a customer may want or need. Identify service package components. So what will be the things that will be included in the package? Determine performance specifications, translate performance specifications into design specifications. Let's say somebody is designing a service for a restaurant. So if you have that example in mind, first one is conceptualize. So how that service will be provided when you open a restaurant, and what will be the package, what will be service package components, what will be performance specifications, like by the time a person takes the order for food and by the time it is delivered, and also maybe how much time it takes to do the billing. So all those are related to performance specifications. Translate performance specification into design specifications. So how you design your service so that if you are talking in terms of time, how you can reduce that time. So for example, the distance from where the food will be brought and served should not be too long. So it should be somewhere it can reach every corner quickly. Translate design specifications into delivery specifications. These are like some of the basic phases in any service design. What are the challenges? So service always is very challenging, and same thing for service design, because of variable requirements. Every person is different and they have their own ways. So that creates challenge. So somebody may be happy with something, but that same thing may not make another person happy. Difficult to describe. Sometimes it is also difficult to describe, like what will make a customer happy. Like somebody who is in a hurry, so they want things quickly. If they order, so the time between order and they get the food should be minimal. Whereas somebody who has all the time in the world and in no hurry, so that person doesn't want you to serve them quickly. In the same situation, two people can have different requirements. There is a high customer contact, so it is important that because the customer is in contact with the service provider, more care has to be taken. Service always has a customer encounter. Now, what are the guidelines for successful service design? So 9 points are given here. So it always starts with, first we define what the service package will be, and then focus on customer's perspective, because that's the critical, because customer is always in touch with the service provider. So one has to look from customer's point of view. Consider image of the service package. So that is again important. Recognize that designer's perspective is different from customer's perspective. That makes it more important that the focus should always be on customer's perspective, not on designer's perspective. Make sure that managers are involved, because ultimately their blessing is needed and their support is needed to take something forward. So they should be involved. Define quality for tangible and intangibles. So tangible, it is very easy. Tangible, defining quality for tangible is easy, but it is the intangibles, and which are more in number for service activities. So that's why it is very difficult here. Make sure that recruitment, training, and rewards are consistent with service expectations. Establish procedures to handle expectations. So there should be procedures available, especially because there is so much of variability involved, that there has to be standard procedures to be followed, especially for exceptions. Establish systems to monitor service, because you need to monitor continuously to see that things are within your control.